Hey guys, Zach here. So today we're going to solve a interesting physics problem together. We are going to figure out which is stronger, the electric force or the gravitational force. How we're going to do that is we are going to take two electrons, place them at a distance r from each other. Both electrons will have an electric charge E and a mass m. And since they will have both masses, there will be a gravitational attraction, and there will be an electric repulsion due to the fact that they have like electric charges. So how we're going to find the actual value of the number of times bigger one is than the other is we're going to do it by this equation. We have the electric force is equal to the number of times bigger the electric force is than the gravitational force, denoted by x multiplied by the gravitational force. So you just solve for x, get a pretty simple equation. And now we actually have to plug in what these forces are. So these forces, this is called this is the electric force. It is given by a 1 over r squared with a constant out front. Same goes with the gravitational force. It's a 1 over r squared with a constant out front. And this is kind of interesting how they have the same form, a 1 over r squared form. So when we take the ratio between them, it will be independent of the distance between them. Just an interesting fact. So here's the force between the two electrons, the electric force. It is given by E squared divided by 4 pi epsilon 0 r squared, where epsilon 0 is called the permittivity of free space. Now the gravitational force is given by Newton's gravitational constant multiplied by the mass of the electron squared divided by the distance between them squared, r squared. So now these values, these parameters, have been experimentally measured, and I write them here. And I just write SI for standard units, meters, kilograms, and seconds. Okay, so you can go to Google and figure out these. Now we just plug in this for here, and we plug in this for here, and we find out what x is in terms of these parameters. And this is the equation for it, right? I encourage you to check this. It's the electric charge squared divided by 4 pi epsilon 0 multiplied by Newton's gravitational constant and the mass squared. And you plug in these numbers right here into here, and on your calculator or on your computer, and you get, drum roll, a very big number. So this is a 4 with 42 zeros. That's a very big, I don't even know how you would say this number. In scientific notation, it's 4 times 10 to the 42. So now you know how many times bigger the electric force is than the gravitational force. One thing to be noted though, these equations are approximate. When you go to really, really high energies, these equations need modified. And the electric force actually at higher energies than what we experience in everyday life gets weaker, and the gravitational force gets stronger. And because of that, you have to modify the equations, and it turns out at some super duper energy they converge into one strength. Alright guys, I thought that was pretty interesting. I'll see y'all in the next video.